Welcome back, class. We're going to go ahead and continue. This is going to be section 4.5, and we're going to go ahead and run through some examples, right? Or how do we tackle these problems? So in the previous sections, we've gone over probabilities, permutations, and combinations, right? Specifically in section 4.4. And this is where we're going to be putting all of that together. All right. See how it all comes together. All right. And right, I'm going to be dealing with probabilities. Right. And one thing we need to go ahead and remember, all right, that if you're talking about probabilities, your value must be between 0 and 1. Right. So more than likely here, there's going to be division going on. Right. So the first question is, find the probability of getting 6 face cards, in other words, a king, a queen, or a jack, when 6 cards are drawn from a deck without replacement. All right, without replacement. So let's go ahead and pull up the cards. Go ahead and pull up that image. All right, the possible cards that I'm able to have. All right. I want us to go ahead and see this. All right, so it's not popping up. Oh, I know what I'll do. Go ahead and just take a screenshot. I'm sorry about that, guys. Give me 1 second. All right, so you have this. All right, so find the probability of getting 6 face cards. All right, so first things first is how many cards are in a standard deck. All right, how many cards? All right, what do we think? Do we remember? We need to remember, right? We need to remember. There are 52, right? There are 52 cards in a standard deck. All right. So I see here that I need to be, I want to go ahead and draw 6 out of 52, right? So in other words, that's going to be my total, right? That's going to be my total, my right? It's going to be my total. In other words, this is going to be a combination, right? Right, because I'm drawing 6 out of a standard deck of cards. Right, but what is my focus, right? We said it was a focus divided by the total. Well, I'm focused on drawing just 6 out of that deck, right? And my focus here, right, are face cards. Right, so how many face cards do I have? That's 12. So in other words, on the top, my focus is going to be the combination of 12, but specifically only drawing 6 out of them, right? Right, and we're going to go ahead and plug this into our calculator, right, to find out what 12 NCR 6 is, right? 12 NCR 6 is. This gives me 924 divided by my complete total, right? The total possible options is, which is a very, very large number, right? It's 203,58520, right? Right, 520. You may leave your answer like this, or you may want to go ahead, right, if you're asked to find a percentage or whatnot. All right, let me go ahead and divide that out, and I get a very, very, very small number. All right, so you may actually want to leave it like this, right, in this form. If you wanted, right, if you wanted to go ahead and show this in scientific notation, this would be 4.54 times 10 to the negative 5 power. A very, very small value, right? And here's just in case you wanted to see what I ended up getting. 0.0, there are 4 zeros. Right. So any these 3 would be valid answers, right? Okay, let's go ahead and move on to our next problem. What do we have here? Number 2. Okay. Suppose the composition of the Senate is 47 Republicans, 51 Democrats, and 2 independents. All right. So one thing with these right off the back is I want to know my complete total. All right. What is my total pool? All right. This is going to be 47 plus 51 plus 2, right? 47 plus 2, that gives me 49, and then 49 plus 51, that gives me 100. All right. A new committee is being formed to study ways to benefit the arts in education. If 3 senators are selected at random to head the committee, find the probability of the following, right? So one thing I already know right off the back is my complete pool, right? My total amount is 100C, with specifically having to choose 3 from there, right? And then I'm going to go ahead and narrow down on my focus, right? So for part A, right? For part A, the group consists of 3 Republicans, all right? So I know when I'm looking at the Republicans, it is a 47 amount, right? There's 47 of them, but I only want to draw 3 from there, right? From a complete pool of 100C3. See what that gives us. Calculator 7. Oh, this gives me 3. This gives me 1, 6, 2, 1, 5. Last one. This gives me 1, 6, 1, 7, 0, 0. Right. If we were to go ahead and 1, 6, 2, 15 divided by that, right, I get 0.11. I'm sorry. 0.1002782. I'm writing these out for you guys, but if, if the question, if it states 3 significant 3 decimal places, right, we would just use 0.100. Right. For B, what do you all think? What do you think? Let's go ahead and pause the video and take a guess. Yes, so this is going to be 100 combination with 3. And I'm looking at Democrats, right? So it's going to be 51 total Democrats, but I only wanted to be able to draw 3 from there. I know what 100C3 is. That's 161, 700. Right. And 51 NCR3 gives me 208. Which gives me 0.1288. Right. Right. And last but not least, a little bit different now, right? A group consists of 1 from each party, including the independent. All right. So in other words, I'm going to be multiplying these with one another. All right. So it's only, and I only need 1 of each. Right. So in other words, I need from the Republicans, I just need 1 times. From my Democrats, I just need 1, and from my independents, I just need 1. Right. Let's see what this ends up giving us, right? So for the Republicans, right, choosing 1 out of 47, I get 47. 51 times 2, which gives me 161,700. Right. 47 times 51 times 2. This gives me 4,794. And this here gives me 0.02965. Right. We'll be seeing more of these, right? More of these kind. Let's go ahead and go to example 3. Right. The red face cards and the black cards numbered 2 through 9 are put into a bag. Okay. So I'm looking at, are put into a bag. The 3 cards are drawn at random without replacement. Find the following probabilities. All right. So let me go ahead and bring this up. Where's the snippet tool right let's go ahead and see what we have here. So the red face cards and the cards and the red face cards and the black cards numbered 2 through 9 are put into a bag. All right, so my focus is, let's see here, what is my focus? So the red face cards, no, there, that's why I can't see it. Give me 1 second. Give me 1 second. Oh, there we go. Okay, so the red face cards, right? Let me go ahead and highlight this in green. All right, the red face cards, right? So it's going to be the bottom 2 rows, right? I'm going to be looking at these 3. Right. So when in regards to red, right, my total, right, would be 6. Right, 6. Let's go ahead and look now at the black cards information. So that is 2 through 9, but from the black cards. All right. So I'm looking at only these. All right. Yeah, so for the black cards, it'll be 1, 2, 3, 4, 5, 6, 7, 8. Meaning, right? And if we wanted to complete pool of these, right? The complete pool of these, this would be 16 plus 6, which gives me 22 pool total. All right, I'll call it pool total or complete total, right? So let's go ahead and get started with this problem, right? The red face cards and the black cards number 2 through 9 are put into a bag. 3 cards are drawn, right? So I already know that my complete pool, right, consists of 22 items, right? And specifically, I'm only going to be drawing 3 out, right? So I know that's going to be my total, right? My total, right? That's going to be go ahead and be my total. They want to know the probability of that all 3 cards are red, right? That all 3 cards are red. So, right, and this is why I went ahead and wrote my red total, my black total, and my complete total, right? If I'm looking at just the red, right, the total that I have is 6, but I only want to go ahead and draw 3 from there, right? That's how my probability would look, right? My focus divided by my total, right? With my focus being all 3 cards being red. So let's go ahead and do that. Let's see what we get. Here I get 20. At the bottom, I get 1540. Right, and this here ends up giving me, these cancel out, so this is 2 over 154 over 77, right? And that is just 0.0130. Very nice. So very similar to the other one, right? It's very similar to the Republican, Independent, Democrat, but we just had to rearrange. We needed to dissect that information, all right? And I highly recommend writing all of that out, like that. 1 card is red and 2 are black, all right? So regarding the red one, right, there's 6 total that I can choose from, and only want 1 being red. And for the cards, I'm choosing from a pool of 16. But my focus that I'm drawing is 2 over that total pool. This here is, I know it's 1540, right? No, that's 1540. All right, we know this here gives me 1. And this here gives me 120. So in other words, I have 6 times 120. 6 times 120 divided by 1540. And I get 0.4675. All right. Very, very nice. Okay, and part C is at least one of the cards is red. Ooh, okay. Remember this, right? Book. I believe your book also had it like this. And we also know, right, furthermore, that if you have the focus added to the negation, so find the probability that at least one of the cards is red, right? If at least one being red, well, that is going to be the same thing as 1 minus the probability that none are red, right? Because at least one, right, says 1 or more, all right? 1 or more, all right, which is the my complement of that would be 1 minus none are red, right? None are red. And what does it mean to be none red? Right, this is just 1 minus the cards being black. Right, it's all being black because none are red, right? So I can just focus on the black cards, right? Because I have information for that, right? So if this is 1 minus, right, this is going to be my total pool. We know it's 22C3, right? And if I'm drawing all 3 that are black, that's going to be 16, right? Total black cards. And I'm strictly pulling these 3 from there. Let's go ahead and see what this gives me. This gives me 560 over, oh yeah, 1540, we know that. All right, let's go ahead and plug that in. And like I said, right, just be sure that whenever you're doing these, your values, your answers are bounded between 0 and 1, right? So here I ended up getting 0, right? 1 minus that fraction would give me 0.6363 repeating, all right? So if I were to stop it there, that's where it would be at. All right, so like I said, with these, just be sure your answers are bounded between 0 and 1 as a way to check, right? Right, and this is one I received a few comments regarding, right? When 3 dice are rolled, find the probability of getting a sum of 7. All right, a sum of 7. So now we're talking about 3 dice being rolled. What I would do is I would go ahead and find ways to add 7 with 3 slots, right? Add 7 with 3 slots, right? Very similar in the arrangement that we had done in 4.4, right? So what's going to be my grand total, by the way? It's going to be my grand total. If you were rolling 3 dice, right? If you're rolling 3 dice, right? And to clarify, yes, we are assuming these are 6-sided dice, right? So no Dungeons and Dragons with more than 6 sides, right? Okay, so what do we think? Well, if one of them is 6, and the other one is 6, and the other one is 6, right? Well, right, that's going to be the total, right? My total sides. That's going to be 6. In other words, that's 6 cubed, which is 216, right? 216 total. All right, and now, right, I want to ask myself, find the probability of getting a sum of 7. What I would do with these, right, is start out with the number 1. All right, when my next number was a 1, what would the other side of the die have to be in order for this to be a sum of 7? Or 5. All right. And that would start again. I would start at 1, and then I would go to 2. All right. I know this is a 4. 1, 3. All right. Oh, that has to be a 3. Right. And you see the pattern going on here, right? And you may be asking, hey, where do I stop? Well, if you were to go 1, 6, well, it's already hit 7, right? And you got to roll 3 of them, meaning this one doesn't count. You would stop here. All right. And then I would go ahead and move on to the 2s as well. 2, I will start at 1, and then see what do I got to add. That's going to be a 4, right? And then I'll go ahead and just fill these in, all right? If you want, you can go ahead and pause the video, all right, and find out how I got those. And again, I would then move on to 3 and still with a 1, all right, and go up that list. All right, 3, then 2, then 2, then 3, then 3, then 1. That's it, right? I get a 7 there. All right. What's next? 4, a 1, and what's that? 5, 7. Then a 4, a 2, and there, and that's it, right? Because if I were to do 4 and 3, that's already hit 7. Right. And if you see a pattern here, right? Yeah, of course, it's definitely a pattern, right? These are locked in, right? This one is increasing and this one is decreasing, right? You can see that pattern going on for all of these, right? For this one, I get 5, 1, and a 1. If I were to do a 5 and a 2, well, that I've already gone over, right? So these are all the possible ways I can go ahead and get a sum of 7, right? If I roll 3 different dice. So this is what do I have here? 1, 2, 3, 4, 5, 6, 7, 15, right? Be 15 over my grand total, which is 216. All right. What does that give me on my calculator? 15 divided by 216. This here gives me 0.069. Right. And yes, right, that value is bounded between 0 and 1. So very, very nice. All right. Selecting books. Find the probability of selecting 5 science books and 5 math books from 14 science books and 11 math books. Again, very similar to the cards, right? Very similar to the red and black cards. I want to go ahead and find out my science total. Science total is 14. My math, yes, total is 11. Right? And my pooled total, all right? You can write complete total or pooled total, right? I would say that is what, 25? Right. Right. Find the probability of selecting 5 science books and 5 math books, right? So in other words, I'm going to be, my denominator, right? My complete pool is I have 25, and I'm going to be, right, withdrawing, pulling, right, selecting 5 and 5, right? So that's going to be 10. 5 from each, right? That's my complete total. And let me go ahead and now focus on the science books, right? On the science books, I have 14 of them, and I'm selecting 5 from there. From the math books, I have 11, right? And I'm selecting 5 from there as well. All right. So our combination formula should look like this. Let's go ahead and see what we get. Right. I got 14 combination 5. This gives me 2002. This gives me 462. This gives me a pretty large number. This is 3268760. All right. And whenever we plug these in, right, I get 0.282958675. Right. Very, very nice. Right. Again, dissecting the problem, right? Getting the totals for the science books, for the math books, and the complete total. And this one was worded a little bit differently, right? Because it's saying you wanted to select 5 from here and 5 from here, and you need to go ahead and count that total, right? The total that you're going to be pulling from there, right? Great. And similar example here with these, right? A football team consists of 20 each freshmen and sophomores. All right. So let me go ahead and write my polls here. For the freshmen, I have 20 total. For my sophomores, I also have 20 total. For my juniors, all right, I have 19. And for my seniors, right, I have 12. Right, let me see, go ahead and find the complete total, right? I like calling my pool total, right? I have 40, right? 20 plus 20 plus 19, 20 plus 20 plus 19 plus 12. This gives me 71. Complete total, right? 4 players are selected at random to serve as captains, right? Find the probability of the following, all right? So I know for A, right, that my pool total is going to be 71 C4, right? If I'm selecting 4 seniors, right, well, the total amount of seniors are 12, right? I'm only selecting 4 from there, right? And let's see what this ends up giving us. 12. The top part I get 495. And for the bottom part I get 7104. This gives me 971,635, right? And if I get 495 divided by that, I get a very, very, very small number, right? Very, very, very small number. So I'll leave it like this, right? We'll go ahead and leave it like that. All right. If you were to have written this out, in case you're wondering, it's 0 points. There are 3 zeros, 1, 2, 3, 5, 0, 9, 4, 5, 1, right? Because of course it depends, right? If how many decimal places I'm asking you. Let's go ahead and do B, right? There is 1 of each. So if it's 1 of each, right, we know my total is still going to be 71 C4, all right, with 1 of each being, well, there's 20. Let's do the freshmen, 20 freshmen, focus on 1, 20 juniors getting just 1, 19, no, that was 20 sophomores pulling just 1, 19 juniors pulling just 1, and 12 seniors pulling just 1. All right, let's go ahead and see what this gives me. Right, and we like these ones, right? Whenever it's 20 combination 1, it's just that number, right? So it's in other words, it's going to be 20 times 20 times 19 times 12 divided by 71 C4, which we said was 971,635, right? This here ends up giving me 20 times 12, that ends up giving me 91,200 over 971,635, right? Which is approximately right, I end up getting here 0.0939, right? See here stating there are 2 sophomores and 2 freshmen, right? So it's pretty similar, right? So my sophomores are 20, and I'm focused on getting 2. And my freshmen, there's a complete total of 20, and I'm focused on just getting 2 by that 71 C4. So this here gives me right 190 times 190 over 971,635, right, which is, what is that, 36,000? Yes, 36,100, right? right? And 190 times 190 divided by 97165. This gives me approximately 0.0372, right? If you wanted all your decimals, right, it would be 15387. And last but not least is D. At least one of the students is a senior. Very similar to the other one, right? I would do the negation, right? I will go ahead and do 1 minus no seniors. Right? If you want at least one, right, then my complement would be no seniors, right? So this would be 1 minus, right? Let's go ahead and see here. The complete total would still be 71 C4. But if I do not want seniors, right? If I do not want seniors, I want the entire other pool except for the seniors, right? Except for the seniors, right? And so you might be saying, do I have to multiply all these out? Well, you're not told 2 and 2 or 1 of each. You know what I mean? So you cannot have like, because there's a lot of combinations for that, right? How many combinations of those can you have? All right. So you would just get the pool, right? The top would be a pool of the smaller pool, which has all the information, just excluding the seniors, right? So if we were to add freshmen, sophomore, and juniors, we'd see that there's a total of 58. Oh, no. That is 2020. That's 59. I'm sorry. That's 59 C. And with these, if you notice, I'm still pulling 4 of them, right? So it's still going to be 4. So in the top, I'm going to have 59 C4. 59. 4, right? So in other words, this is 1 minus, what was at the bottom, right? That pool right there is 635. And the top one is 20. Let's see, R4, right? And this gives me 4845. Let's see what this ends up giving me. 1 minus 4845 divided by 971,635. I end up getting 0.99501,356. All right. All right, let me go ahead and make sure I found that right. 59 C4. Oh, no. You guys are right. I had 20 C4. I'm sorry. This is because I realized that number was too close to 1. Right, and we know that the large pool, that's a pretty big pool, right? With freshmen, sophomores, and juniors. So 59 NCR4, I get 455,126. There we go, 45126. Now let's go ahead and find that 1 minus that. All right, gives me 455,126 divided by 971,635. I get 0.468421, or in other words, that is giving me 0.5316. Right, and if you wanted the complete value, right, not rounded, would be 1587479. Right, well, this is it for section 4.5, and I'll go ahead and be seeing you all in the next section. Thank you.